let's all learn how to make some awesome decorators right now. Like now. Okay, so hopefully in this talk, I will help you better understand functions and then teach you a little bit about why decorators are special kinds of functions, and then show you an example of a common decorator, and then give you a tip on building your own super awesome decorators. Okay, so decorators is a function, and you know functions because you use Python, you use functions all the time. In fact, let's just go ahead and make a function right now, like right now. Bam, done, made a function. That was easy. Okay. But what actually are you doing when you define that function? Are you defining an instance of a class? I don't know. Are you? I don't know. Let's find out. How would I find out? Well, what you would do is you import the, from the inspect module, you import the isClass function, and then you call the isClass function on the function we just created, add2. Bam. What? That's weird. It's not actually a class. Well, if it's not a class, then what is it? What is it? You know, like, what is it if it's not a class? Well, turns out that what you're doing when you use that def keyword when you're defining your function is that you're not creating a class. Instead, what you're doing is you're calling the dunder-init method on this built-in class in Python called the callable class, and it's called the callable meta class. And so when you are defining your function, you're actually instantiating the callable meta class. Okay, well, if Python didn't come with this built-in callable meta class, what would happen every time you had to define a function is you would have to create your own callable meta class. And this is like simplified version of the callable meta class. So you know classes, you've seen a class before, and the way in which you instantiate a class is by using these brackets. Aha. Well, see, this is where all the confusion comes in whenever you're trying to use create an instance of the callable meta class, right? So when you use the brackets the very first time, what happens is you're making a call to this dunder-init method on your callable meta class. But when you use the brackets the second time, what happens is that you're making you're using the instance to call the method dunder_call on your callable meta class. And that would be fine if we only wanted to use functions once, but the advantage of functions is that they are super reusable, and you can call a function with different arguments multiple times. So that's why when you create a function in Python using the def keyword, what you're doing is you're instantiating the callable meta class, and then every other time, all you're doing is calling the dunder_call method. Okay, so to recap part one, functions are callables, decorators are functions, decorators are callables, and there's this callable meta class, and it's completely blowing your mind right now if you're hearing this for the first time. So let's move on to the second part, right? And you're saying, hey, Phoebe, you keep saying that decorators are functions, but decorators, if you've used decorators before, they don't look like functions. They don't, they look like this. This is what they look like. They are that thing after the @ symbol above your function definition. And that doesn't look like a function at all. So what is this? Like, what is going on here? Well, you're going to have to trust me. I'm telling you it's a function, and I'm going to show you how it's a function. It's not just any function. It's a special kind of function. Why are they special kinds of functions? Well, they're special because they take a function as an argument, and they return a function sometimes. So the decorators are special functions because they are functions of functions. They are, and since functions are callables, they are callable callables. Okay. This is really hard to explain with words, so instead I'm going to jump into an example and hopefully you'll understand it. So let's revisit our function definition. That was simple. Let's move on. Let's define a decorator, which I will explain later, and then let's call that decorator. Okay, so what you know if you've used decorators is something like this. When you run the function without the decorator, you get a plain result. But if you run the function with the decorator, you get a fancy result. Okay, so what's going on here? Well, let's look more closely at our definition here and then run it a couple more times. So I have defined my function and I have defined my decorator in my namespace. And then I call my function without the decorator, and I get a plain version of the function. Okay, well, then look at our definition of our decorator. It is a callable that takes a callable as an argument and returns a callable. Okay, so then if you are using that function in our namespace with our traditional function notation, what we would do is we would say new decorator, use our brackets, insert our old function definition, and replace that function definition in our namespace, and then call it using some arguments. And then, wow, we just decorated our function. But this is super confusing. Why is this super confusing? Because we have two different versions of our function in our namespace. We have an undecorated version of our function, and we have a decorated version of our function. And so Python, in order to avoid this horrible confusion, gives us the @ notation. So then the @ notation is the exact same thing that happens here, except for it is using the @ notation above the function definition, and that ensures that there's only one version of the function in our namespace. So then when I run my decorated version of the function, I don't have the confusion of an old, an undecorated version running around. Okay, so why is this useful? Well, it's useful because when you are creating functions, oftentimes you're creating things in a series. You're creating like add 2, add 3. And then what happens is that you are trying to avoid repeating yourself. And one good way to avoid repeating yourself is to take all of the repeat stuff that happens before you call the function and after the call of the function, pull it out of the function. And now that's all contained in a decorator. And then that means that everything that keeps that is unique to the individual function is placed inside the function definition. That allows you to save some typing and be super clear. Okay, so at this point, you should understand that a decorator is a callable. It is a function of a function. Okay, but if you're familiar with decorators, you're saying, hey, there are decorators that don't take arguments, but there are also decorators that have arguments. Well, what do I mean? Some decorators look like this, which means that they have the @ notation and nothing after the words. And then other decorators look like that, where they have the @ notation, the decorator, and then all of these this stuff after the decorator. So what's going on here? Well, if decorators are callables, then decorators with arguments are callables. They are functions that take in arguments and then return a decorator. Okay, that sounds complicated, and then I show you this complicated example, so it must be really complicated, but I'm going to walk you through it. I hope you can see it. And if you follow with me, I swear it'll make a lot more sense. Okay, so we have our decorator definition here, and we have our function definition here, and then we call our function here. And if we call the undecorated function, we get a plain result. But what if we don't want to call the function yet? What if we want to replace that function in our namespace with the output of our decorator? Well, first we have to create the decorator by passing arguments into our function. And so what happens is we pass this hello SF Python into our function, and we return a decorator as the result of our function. And how I can prove that by following our print statements. So our print statements start by saying generating the decorator. Then after you create the decorator, it says the decorator has been created. And then when the decorator is called on a function, then it says, hey, this decorator was created with this argument. And that's what I see as my result. Okay, so this notation then becomes completely equivalent to this notation here at the top of our function. So what happens in this statement is equivalent to what happens here. And I can run it again, and bam, now I can see that I've created a decorated function, and then I can actually call my function and see that my function is actually decorated. Okay. If your brain is melting, this stuff is super complicated. Bear with me. Okay, so up until this point, we have used super familiar function notation with the DEF keyword to create our decorators. And we've created decorators with arguments that are callables. That means that they're functions within functions within functions, right? But in Python, there always should be one obvious way to do something, unless there is an equivalent way to do something. And then you have to ask yourself, what would happen? What would I do if you're looking at this definition, right? I run the first version of this. It takes an argument, creates a decorator, returns that decorator, uses the decorator to modify my function, and then calls that function on my arguments. Okay, well, what happens when I run this?
Hey, Phoebe,
hey,
sorry for interrupt. Is it
up?
possible to zoom in the screen a little bit?
Zoom in a little bit?
Yeah,
Is that better?
thank you.
Sorry about it.
No worries.
Okay. Right. So if I use the second definition of my decorator, what happens is that I take an argument, I run the dunder init on my class, I return an instance of my callable class, then I use the instance to call on a function and return a wrapper. So in essence, to decorate my function. And then that returns an argument. Okay. So far, I have managed to show you how callables work, and you should better understand decorator syntax. So let's move on to show you an example that you probably use. You might use the @to-do decorator, or you might see it used. And so what's going on here? Well, oftentimes if you're creating a function and you're not really ready to, you're not really finished with it, like you put @to-do on top of your function definition, and what's actually going on here is it's taking in the function, it's pulling a bunch of information about that function, and then it's creating a brand new function to replace that function that says, hey, this hasn't been done yet. And then I can run it, and it says, hey, sorry, we haven't managed to land on Mars yet. It's still work in progress. So, okay, now at this point, I'm out of time, essentially. And so you have to take my word for it, right? But I've looked at the source code for LRU cache, unit test.mock.patch, and click. And they follow a simple pattern. That simple pattern is the same decorator thing where they replace the function with a new function, but they combine it with context managers. So that means that you can localize the context based on arguments to the decorator. And that is my super secret tip for how you would make an awesome decorator. Is you would try to find a way to combine context managers and decorators to create awesome decorators for the awesome decorator list. Thank you for listening to me. It's always fun. I have to thank Simeon Franklin for being teaching me 2 years ago. I have to thank James for getting me to do this. I have to thank Grace for making this happen. And I have to thank Mark Rice for helping me out.